So let's spend a little bit of time focusing on the mechanics of these conversions. If you feel good about them, then you can skip this. But let's calculate the pH of seawater in this first example that has a hydroxide ion concentration of 1.58 times 10 to the minus 6. So pause the video, see what you don't know, and see if you can take a stab at it. So what we always know, and is always true, at room temperature, which we're implying here, is that Kw is equal to the concentration of hydroxide times hydronium ion, and that it's equal to this value, 10 to the minus 14. So if we know hydroxide, then we have to know the hydronium ion concentration. And remember, pH is the negative log of that. And so this is an example of a problem where you're being asked the pH, which is speaking to the hydronium ion concentration, but you're given the other species. But remember, if you know one, you know the other, because you always know this is your key to both. So we can plug in the value for hydroxide and solve for hydronium ion concentration. So we get 6.33 times 10 to the minus 9 molar. But we can't take the negative log of that directly, because that would give us pH, or that would give us, that's correct, we can take that. That'll give us pH, so we need to do the negative log of that. That gives us a value of 8.199, and I've underlined the significant digits. So remember, 3 going in and 3 past the decimal are in the mantissa, because 8 here is simply a placeholder for the zeros in this real number. So I want to make it really clear that we can go in either direction here and what the sig figs would look like if we went the other direction. So let's just assume, we already know the answer to this, but let's just assume, because we can see it, that we want to compute the concentration of hydronium ion from the pH. Well, how would we do that? Well, we know that pH is equal to the negative log of this. How do we go the other direction? What's that mathematical form look like? Well, remember, when we're writing log, we're really implying that this is log base 10. And so when we want to get rid of that log term, we would just simply raise both sides to 10 to the power of. So both sides get that. And if we did that, that would give us a value where H is equal to negative of this, which isn't what we wanted. So that's why we would raise this to 10 to the minus pH. That's going to give us the proton concentration, which is really just the inverse of the negative log that we talked about before. So see if you can punch this number in and get the number of sig figs, and then figure out what that sig fig rule is when you're going the other direction. So if I punch that into the calculator, it gets something that looks like this. I have not yet conserved my significant figures. I'm just writing out a bunch of digits. But remember that the values in a logged number, which pH is always a logged number, the actual digits that are significant, that are real, are only those past the decimal. So there's only 3 sig figs here, which means that we need to conserve 3 sig figs over here, which would mean only those values, 6.3 and 2, and these would go away, and that would be our final answer.